Chapter 3 review, question number 2. Graph the function g of x equals x plus 2 over x squared minus x minus 2 after finding the following. So on your test, you have one question where you're finding a domain of one rational function. And then you're finding x and y-intercepts of a different rational function. And then you're finding vertical asymptotes of a different rational function. And then you're finding the horizontal asymptote of a different rational function. So on our assignment, we're doing all of those things on the same function. But on your test, it's split up into different, completely separate problems. Okay? Oh, and horizontal. Maybe I already said that. Okay, so domain. So we do domain by looking at the denominator only. So we're going to factor the denominator. We're going to just put corresponding to me. Oh, come on. Computer, you could deal with doing a Google Meet and a recording all at the same time. I promise you can do it. I faith in you. Haha. So I'm going to factor the denominator, which gives me x to get my x squared. And then I need factors of -2 that add up to -1. So I think that's a -2 and a +1. Now that's for the domain, right? So then we look at what makes these negative. So that would be x does not equal 2, and x does not equal -1. That's kind of the shortcut way I taught you to do domain, but there's the official interval notation way, which would look more like this. -infinity to -1, -1 to 2, and 2 to infinity, which tells us there are gaps in our domain where those asymptotes are. Right? And the parentheses tell us that they don't exist. If it was brackets, then there would be no point in doing that because brackets include everything. All right, x and y-intercepts. So for x-intercepts, we set the numerator equal to 0. So x plus 2 equals 0. Solve that so we get x plus 2. So that would be a point at 2, 0 for our x-intercept. Yep. Thank you. Awesome. And then to find the y-intercept, we plug 0 in for x. So we get 0 plus 2 over 0 squared minus 0 minus 2. So we have 2 divided by -2, which is -1. So we have a y-intercept at 0, -1. All right, vertical asymptotes. So vertical asymptotes, because we're doing the same problem for every step, we can go back to step 1 on what we did there and use that to help us do step C. But if this is an entirely different problem, of course you have to start over with your factor. So anyway, this particular problem, we have x plus 2 over x minus 2 times x plus 1. Now, if that had been an x plus 2, then those would reduce, and we would only have one asymptote at -1. But because that's a 2 and because those factors are different, nothing reduces. That means we do have 2 asymptotes. We have an asymptote at x equals 2 and at x equals -1. But if that sign had matched, if those would have canceled, that would have been a hole, and there would just be one vertical asymptote. So remember that little thing we learned way back when? Okay. Horizontal asymptotes, or slimes. That's the one that has the 3 rules. First rule is the degree of the top less than the degree of the bottom. So that's the degree, that's the rule that's going to happen here, where the degree in the numerator is 1 over the denominator, which is degree 2. How do I tell degree again? That's clear back from chapter 2. That's the highest exponent of each polynomial, right? So when that happens, the horizontal asymptote will be at 0. Now, if the degrees are the same, we do the leading coefficients. So if there had been a squared on the x squared plus 2 on the top, then the degrees would both be 2, and we would take those leading coefficients, which are 1 and 1, and divide those so that our horizontal asymptote would be at 1. That's if the degrees were the same. If the degrees are not the same, the degree is less on the top and bottom, so y equals 0. Right? And then the third rule, so I just went over rule 1, is degree on top is less than bottom, so y equals 0. The second rule is degrees are the same, so it's the leading coefficients divided. And the third rule is if the degree on the top is larger than the bottom, then we have a slant asymptote, we have to divide it. Okay, holes. So we talked about what would give us a hole. That would be if something had reduced, but nothing reduced. So there's no holes, right? So now we put everything together and create our graph. I'm going to make my screen a little bigger so I can see everything at once. So I've got an x-intercept at -2, 0. I have a y-intercept at 0, -1. I have vertical asymptotes at 2 and -1. I have a horizontal asymptote at 0. Wait, how can we have an x-intercept if we have a horizontal asymptote? Well, as we talked about, it is possible for the graph to cross a horizontal asymptote. Okay. So then, in order to figure out what this graph actually looks like, we need to plug in some other points. Right now, all we have is these 2 points and a few guidelines. So just plugging in a few more points is helpful. Oops, that's not what I meant to do. I want my regular pen, not my line drawer. So plug in values for x and get out values for y. I probably want something else over here so I can see what's happening. So maybe like -3. And I would just plug this into my factored form here. So -3 plus 2 is -1, and then -5 and -2. So if I can remember all that, -1 divided by +10 is a -1/10. So -1/10 would be about right there. Okay, let's maybe plug in 1. So 3 over -1 times 2. So -3/2. I feel like I need to be writing these out. My memory's not doing great today. So 1 and -3/2, so that would be about right there. Then, just double checking on my numbers, sorry. Maybe 1 at 3. So 3, plug in 3, we get 5 over 1 times 4. So 5/4. So that would be about right there. This is kind of hard to tell what's happening. I know you have an answer key there that I feel like I want to keep with. If you look at your answer key, is that doing that? Nope, it's not. This is a painful problem. I promise the graph on the test isn't this bad. Okay. It's a select equation that goes with the graph. And it's a completely different problem than the other problem. So there is no problem on this test that had you actually do all of this for one problem. So.
And you don't have to construct it in some way.
Yeah, it gives you the graph and you select the correct equation, which if I remember right, that was one of the problems that went the worst on our last test. Do you guys remember that? Okay. Right there it is. Interesting. So in order to really know what this graph is looking like, I guess I should have technically plugged in some other points. Although, I feel like these 2 points do give me the general idea that this would go like this. And, you know, really to be honest, to get an accurate picture, you would need more points, right? would take a while. And then the fact that there's no multiplicity with any of our zeros means that this is not going to go the same direction as that, which helps us make sense of the fact that this goes like this instead. But seriously, to really know that, you would need to plug in a bunch more points to really just get an accurate. Doing that on a test is going to take a lot of time. So, fortunately, it won't be that bad. Okay. Are we good with like all the other details? All right.